Now we are going to discuss about microscope, simple microscope or a magnifying lens. Means in earlier class we have discussed about that distinct defects of vision, and now we are going to discuss about a simple microscope or a magnifying lens. Microscope is nothing but we can see the small object in large size. Is nothing but that the magnified size of image can be seen by using the simple microscope or a magnifying lens. Nowadays we are using widely in the gold shops also, watch mechanics and every mechanics. Whenever the small objects mechanics, they can see the smaller objects by using the simple microscope, magnifying lens. The sizes can be clearly seen by using the magnifying lens. So that here this construction of simple microscope will be consist of one biconvex lens, and when a object is placed at a distance of distinct vision at the normal time, when a object is placed near the distinct vision of D from the eye, means whenever without this magnifying lens, if the object is placed at this place, this is placed and this is our eye. Whenever we have seen that one, we can see the image here that the distinct vision from the eye to the object is D. Distinct vision may be D with the visual angle. Whenever it is placed, that is the visual angle be the visual angle. What is the mean by the visual angle? Means the angle subtended by the object with the eye. Means this one is that whenever eye is placed in this place, then the angle made by the object is called a visual angle. Means the angle subtended by an object with the eye is called as a subtended visual angle, that is alpha. Whenever there is no any convex microscope near one, the lens, there is no near lens. So that's why the angle made by the eye is alpha. So that here the tan alpha is equal to, means when the object is like this, then at a distinct vision of D, then this is I. When it is making an angle of alpha, then we can get that the tan alpha, means here tan alpha is equal to OJ by D. OJ means opposite by adjacent. Opposite is OJ and adjacent will be D. So OJ by D, consider say equation number 1. Consider a convex lens is placed object between the object and eye. This is the optical center. Between the object is placed between the optical center to the principal focus. When the object is placed between the optical center to the focus, wherever we consider the convex lens, then due to that lens, the erect, virtual and magnified image can be formed. Erect and virtual magnified image can be formed at a distance of D. Whenever the eye taken to the near to the lens, when the eye taken to near to the lens, the distinct vision, means the distance between the object, means optical center to the formation of image D is nothing but IC. CI or IC will be nearly equal to the distinct vision, G. So the erect and virtual image can be formed. So that's why when the eye close to near that, then the distinct vision will be equal. When the lens is placed, means like this, when the lens is placed from the eye, the image is formed at a distance of D. The image is formed at a distance of D from the optical center with its visual angle will be beta. With post the placing the lens, the visual angle with the eye by the object is alpha. So that's why we have took that tan alpha is equal to OJ by D, considered as equation number 1. And after that, here when the convex lens is placed between the eye and the object, when the object is placed between the optical center to the focus, then some of the magnified erect virtual image formed in the side of the object. So here it is that when the object is placed in this place, then the behind the object that virtual image is formed. The magnified erect virtual image formed due to the biconvex lens or simple microscope. So that's why here at a distance of d, that image is formed at a distance of d, and with the visual angle is beta. With the visual angle is beta, and at a distance of d from the center to the image formed. So here the how much it is, what is having the magnifying power by the lens, means the magnifying power of a lens, means the magnifying power. The magnifying power of a lens means is nothing but the angle subtended by the image with the eye, means the angle subtended by the image with the eye is beta by the angle subtended by the object with eye. The angle subtended by the angle subtended by the object with the eye, means the ratio of the angle subtended by an image with the eye to the angle subtended by an object with the eye is called magnifying power of the microscope. So here it is that the angle subtended by the image at eye is beta, and angle subtended by the object at eye is alpha. So whenever, since these beta and alpha angles are very small, so we are taking their tangents. By taking the tangents, m is equal to tan beta by tan alpha, that is equal to Ig by d cross by d by Oj, because of tan alpha is equal to Oj by d. Oj by d means that it will becomes denominator to the denominator, so that's why we are reversing that one. Then we can get cancelled, then we can get that Ig by Oj. Cancel equation number 1. Is nothing but we can write that heights also, because of h will be the whenever we take the object height is h, and whenever image height will be h dash, then we can write that image h dash by h also. This is also one of the magnification. So then if from the triangles we can write that here, when from the main image, the schematic image of a simple microscope, by applying that, then here that this is a COJ and CIG are the similar triangles. COJ and CI is the similar triangles. By the similar triangles also we can write that, by the similar triangles the CIG and COJ are the similar triangles, means in diagram COJ and CIG are the similar triangles. Similar triangles, whenever we write the similar triangles, then we can write that the two opposites are two adjacents. When we write that, then we can get here Ig by Oj, m is equal to Ig by Oj is equal to, then this is that, next we can write that is Ci by CO. Ci by CO means both distances we can write that. Here is that Ij means the height of the, we can take that is m is equal to, we can write Ci distance. Ci we are measuring the distances from the opposite direction to the incident ray, so that's why this becomes Ci is equal to V. Actually this distance will be V, so minus V by CO is also distance minus U, that is equal to V by U. But we know that V is equal to D. From the relation we can write that D by U. D by U. So here is that, this considered equation number 3. D by U considered equation number 3. Then from that equation we can write that here from lens formula. From lens formula we have that is 1 by V minus 1 by U is equal to 1 by F. 1 by V minus 1 by U is equal to 1 by F. From that we are measuring, we are substituting these details whenever all the distances can be measured from the optical center, and also the distance of the object and distance of the image both are in the opposite direction to the incident ray. So we are measuring in the direction, and focal length will be in the direction of the incident ray. So that's why it becomes that is 1 by V becomes minus V, minus 1 by U becomes minus U, minus into minus plus U is equal to 1 by F. From this relation, if we write that, then we know that minus V is equal to D. From the distance of object is V D. So that's why 1 by d plus 1 by minus d plus is equal to 1 by f. 1 by f. On both sides, if we multiply that v, if we multiply that d also, we can write that multiplying with d on both sides. On both sides. Both sides, we can get that minus d by d plus d by u is equal to d by f. D get cancelled. Whenever we can get that minus 1 taken to this side, then d by u is equal to d by f plus 1. Means we know that what is d by u from the equation number 3, that is a magnifying power m. So that's why magnifying power m is equal to d by u, that is equal to 1 plus d by f. To find out the near point is nothing but we can find out the near point by using this magnifying power. However, the magnifying power of the lens by using this one. If we want to see the spectacles, means spectacles by using this formula magnifying, how much the magnifying E requires, then by using this formula we can calculate the value of magnifying power of the lens by using the magnifying power of the lens by using this formula. Once again, when before placing the object here, first the image is placed, the object is placed at a distinct vision of d from the eye, then the angle subtended by the object, visual angle will be alpha. So from that we got that tan alpha is equal to, means tan alpha, whenever the object is placed naked to the eye, then this is the eye, then this will be the alpha object, then it will be at a distance of d. From the distance of d we got that tan alpha is equal to Oj by d. Then also after that, when the convex lens, single convex lens placed, then object is placed between the optical center and focus, then we can get that some of the virtual, erect and magnified image. It can be seen in the side of the object. So then the magnified image, that visual angle will be the beta, visual angle will be the beta when the lens is placed, when the convex lens is placed. Then we can get that at a distance of d image is formed. So that's why from that tan beta is equal to Ig by d. So from that relation we can get that the magnifying power, we can beta by alpha, then tan beta by tan alpha, means the angle subtended by the object image by an eye, and the angle subtended by the object with an eye. So that's why m is equal to tan beta by tan alpha. From that calculation we can get that Ig by Oj. So but we know that from that COJ and CIG are the similar triangles, means COJ and CIG are the similar triangles which is angle subtended alpha and beta. So that's why here we are taking that angle triangle COJ and triangle CIJ are similar. So that's why m is equal to Ig by Oj, that is equal to Ci by CO. Ig by Oj means the height of the object, the image by height of the object is equal to the distance of the image by distance of the object. So by taking these values, then we can get that we know that Ci means the distance from the distance of image from the optical center will be minus V. The image is formed V, because of opposite to the incident ray we are taking that minus V, as well as the object is also in the side of opposite side of the incident ray. So that's why minus U, minus V, minus U. Ci is equal to minus V, CO is equal to minus U. So from this we can get that the value V is equal to D, we know distinct vision, the angle whenever the eye taken to the near to the lens, then the distance of image is found is equal to the nearby equal to the distant vision D. So that's why that is V is equal to D by U. Consider it's equation number 3. So from this lens formula, to find out the magnifying power of a microscope, then from the lens formula 1 by V is minus 1 by U is equal to 1 by F. that is we know that the values can be taken from the optical center to the distances can be measured, all the distances can be measured from the optical center. So that's why the image formed in the side of the object. So that's why here the image distance will be v is equal to minus v, and u is also minus u, and but the focal length is formed in this direction, in the direction of the incident ray. So that's why here that is 1 by plus f. So from this equation v is equal to d, we know that, then we are substituting that if we multiplied with d on both sides, then we can get the d by u is equal to d by f plus 1. Then we know that d by u from the equation 3, from equation 3, then we can get that m is equal to d by u. From that m is equal to d by u, we can write that d by u is equal to 1 by 1 plus d by f be the equation for the magnifying power of a microscope. This is about a simple microscope.